Our next section here in our solving unit is solving by factoring. So we are going to bring back the concept of factoring we did and apply it to how does that help us actually solve an equation. Because if you recall, all we did was actually just factor. And so remember, factoring looks like this. If we had a type of problem that looked like this, so what we did in the past is we just factored this. Okay, so if you remember, factoring is looking for the two binomials that multiply back to get our original problem. So when we had a 1 in front of our x squared, factoring was really easy. We looked for factors of 4, the c value, that added up to the middle value. Okay, so what we did is, remember, we listed out like factors of the last number. So 1 and 4, 2 and 2. And so we did sort of a guess and check method. So we know it's got to start with x times x. And I'm going to test out, is it 2 times 2? So I'm looking for numbers that add up to 4. And yeah, 2 plus 2 is 4. So we went like this. We said, okay, it's x plus 2 and x plus 2. Now we're going to add an equal sign to our problem, and we're actually going to figure out, well, what are the values of x to make this true? So let's start with this first idea, this zero product property. So it says here, for every real number, a and b, okay, let's just put some values there. Let's say the numbers are 2 and 6. If a times b equals 0, then a has to equal 0 or b has to equal 0. So what I have right here is actually not valid. So in order to have two numbers multiply to 0, doesn't one of them have to be 0? So if I had 2 times 0, yeah, that would be 0. Or if I had 0 times 6, that would be 0. So what we're saying here is, look at this next example right here. If x plus 3 times x plus 2 equals 0, so I'm going to consider that my a value times my b value. Well, one of those has to be 0. So what we can do is we can rewrite each factor and separately set it equal to 0. Because I'm trying to ask myself, what does the value of x have to be to make the factor of x plus 3 add to 0? And you probably could look at this and say, well, if it's x plus 3 and I want it to be 0, doesn't that have to be negative 3? Because negative 3 and positive 3 adds to 0. And actually, that's what we end up with. So if we come back over here and we solve this, I would take away 3 from both sides. And so I end up with x equals negative 3. Okay, and I'm going to have the same thing over here, x plus 2 equals 0. So if I take away 2 from both sides, I end up with x equals negative 2. So I get two answers here. They're not going to be like plus or minus 3 in this case because I have two different equations here. Okay, so that's called the zero product property because I'm taking the product of factors and setting them equal to 0. All right, let's do that example, this first example here. Let's apply that. So I've got x plus 5 times 2x minus 6 equals 0. So the key here is I must have a 0 right here, which I do. So here's what I'm going to do. I'm going to set x plus 5 equal to 0. And I'm also going to set 2x minus 6 equals 0. Okay, because ultimately what I'm doing is I'm saying, what does this number have to be to make this parenthesis add up to 0? And you probably can look at that and say, well, that's got to be negative 5 right there. This one might require a little bit of thought because I have to take a number, multiply by 2, and then take away 6 to get it to equal 0. So that's why we generally just branch into these two equations. Okay, so I'm going to just follow through on the first one. So if I have x minus 5, or if I take away 5 from both sides, 0 minus 5 is negative 5. Solution number 1. Okay, solution number 2, I'm going to solve it like I would normally. So I would add 6 to both sides. So that would give me 2x equals 0 plus 6 is a6. And then I can divide by 2 on both sides. And then I would end up with x equals 3. So my solutions are negative 5 and positive 3. All right. So again, if I were to graph this, let me do a real rough sketch here. So I'm crossing at -5. I'm crossing at 3. I know it's opening up because the a value is 1, and so I'm just going to just real roughly something like that. Okay. I don't know. I didn't calculate the vertex. I just made a really rough estimate. Okay, let's bring in factoring here. Steps for using the zero product property in the form of, this is a trinomial, ax squared plus bx equals 0. Step 1, set the equation equal to 0. This is a must. I'm going to highlight this. So I have to have everything equal to 0 before I even start factoring. All right, number 2, factor a GCF. If it doesn't exist, we can skip it. Then we factor the trinomial. Then we're going to use the zero product property to set each factor to 0 to find our solutions of the quadratic. Okay, number 1. I am going to set the equation equal to 0. Already done. Okay, this is good. I've got it like that. Okay, number 2, I'm ready to factor. Is there a GCF? Okay, I'm going to say here, no GCF. Step 3, we're ready to factor. Okay, I know that it has to begin with x times x. So I need factors of 8 that multiply to 6, or that add to 6. So my factors of 8 are 1 times 8 and 2 times 4. Well, 2 plus 4 is 6. Okay, so I'm going to be able to use 2 and 4. And they're all everything's going to be positive because I'm multiplying positive and adding positive. All right, bring over your equals 0. Now we're ready to set these equal to 0 separately. So I'm going to solve x plus 2 equals 0. I'm going to solve x plus 4 equal to 0. And those are my solutions. So I'm going to take away 2 from both sides here. So I get x equals -2 for solution. I'm going to, on the second equation, take away 4. And so I would have x equals 0 minus 4 is a -4. So I get 2 negative solutions here for number 2. Okay, let's keep going. Number 3. All right, step 1, set it equal to 0. It's not equal to 0 yet, so I need 88 to move over here. So I need to do the opposite when I move across that equal sign. So since it's positive, I need to take it away from both sides. So I now have 2x squared minus 5x minus 88 equals 0. Okay, GCF. I do not have a GCF. No GCF. Okay, step 3, we are ready to factor. So I'm going to start here. Okay, now I have a number bigger than 1 in front of x squared. So it's got to be 1 times 2. Okay, so I know it's got to be x and 2x. But I have several factors of 88. So I'm going to list them all out. 1 and 88. 2 and 44. A 3 will not go into 88. 88 divided by 4 is 22. I know a 5 won't go into it because it doesn't end in 0 or 5. 88 divided by 6 is not a whole number. 7 doesn't work. 8 works. 8 times 11. And that's probably all we can get. 8 and 11 are pretty close together. Okay, let's start with 8 and 11. Okay, so I like to start with the bottom two numbers. 8 and 11. And I'll figure the negative out later. So remember, I have to check. Do the 2 outer plus or minus the 2 inner, do I get my -5? So 11 and x is 11x. 8 and 2 is 16. Okay, I can do this. 16 minus 11 is 5. So I want it to be -5. I need the 16 negative and the 11 positive. So that means I need the 16 negative. So that came from -8. The plus came out of 11. Okay, now I'm ready. I'm going to go ahead and erase this. Now I'm ready to rewrite the two equations. Separately set them equal to 0. Factor number 1, and then factor number 2. Okay, now we're going to solve. So I'm going to add 8 to both sides. So it looks like I get x equals 8 on the first one. Second one, I'm going to have to take away 11. So 2x is going to give me a negative 11. So divide by 2, I get x equals. Now I can leave it as negative 11 over 2, but that is exactly negative 5.5. So you can write it as a decimal if you want, since you didn't round it. I'll just circle both. Okay, that's the general idea on factoring. So you're going to spend most of your time factoring. Then the solving should be pretty easy because you're just setting them to 0. Okay, will you stop the video and move on to 4 and 5? You can also do 6. I'll come back and work 6 with you, but go ahead and pause and do numbers 4 and 5. All right, so we're moving 48 over. Okay, we're ready to factor. No GCF here. Okay, I'm going to go with 4 and 12 because I can, if I do positive 4 and negative 12, I can get that to be a negative 8. Positive 4, negative 12, and I do still get negative 48 here. Okay, let's write two equations. X plus 4 is 0. X minus 12 is 0. So take away 4. X equals negative 4, and then add 12, and so I get x equals 12. All right, number 5, I need to move over 21. 3x squared minus 2x. So notice I'm writing it in standard form. Okay, let's factor. Okay, I have factors of 3 are 1 and 3. Factors of 21, 1 times 21, 3 works, 3 and 7. So I know it's got to be x and 3x. There's no other combination on the first term. But the second term, I'm just going to test out. I'm just going to throw in my bottom set of factors. And then remember, I'm checking the 2 outer plus or minus the 2 inner. So x and 7 is 7x. 3 times 3 is 9. Okay, I can get negative 2 here. If I make the 9 negative and the 7 positive, that will add to a negative 2. So 9 came out of 3 times 3, so this has to be negative, positive. Okay, now don't forget your equals 0 over here, because now you can branch into the two equations. So x minus 3 equals 0. 3x plus 7 equals 0. And so if I solve, I can simply add 3 on the first one. The second one, though, I need a couple steps. So I'm going to take the 7 away, move it to the other side, and then divide by 3. Now, 7 divided by 3 is a repeating decimal, so I'm leaving it as a fraction so I don't lose any digits when I do any rounding. Okay. Well, if you did number 6, you might fast forward to the end. If not, you can work through it with me. Step 1, let's move the 30 over. 2x squared minus 4x minus 30 equals 0. Now, I have a GCF here. So I can divide a 2 out. So your GCF is a 2. So it just makes life easier when you factor. So divide everything by 2, and I'm going to have x squared minus 2x minus 15. Now, the 2 just can really disappear because here's what happens. If I come through here and divide both sides by 2, see what happens over here is I get 2 divided by 2 is 1, and then over here 0 divided by 2 is still 0. So I can, in essence, really just ignore the GCF for solving purposes. Oops. So you don't have to necessarily divide by 2 on both sides, but I wanted to do that just to show you that it really doesn't impact the answer. It just divides off to 0. Okay, factoring out. So I just have x times x, so I can look for factors of 15 that add up to 2. So 1 and 15, 3 and 5. So I can make 3 and 5 add up to a -2 by making 3 positive and 5 negative. So if I put that in my factors, add 3 and take away 5, and then verify, you still get a -15, and I do when I multiply these guys. Okay, we are ready to solve now. Separately set them equal to 0. So take away 3, take away 3. So it looks like I get -3 as one solution. Add 5, add 5. So I get +5. Okay, so that is solving by factoring. So if you have any questions, as always, feel free to reach out to me and ask those questions.